Hi everyone, good morning. It's a very cold day and I hope you all are well and you are in good condition and make sure you stay warm. So I'd like us to do some problems which I said I'll give you one of the problem in your exam, and this particular problem I'm solving is quite important. You have to make sure you understand it. So we are looking at the epicyclic gear train analysis. So one of the methods in gear calculation is the tabular method. And this tabular method is mostly applicable for epicyclic gears. So it is mostly applicable for epicyclic gear. And the angular velocity for the gear train for epicyclic gear is given by this formula, which is the angular velocity for gear with respect to the angular velocity for arm and the angular velocity for gear and arm. So now those are the three main variables you need. But we all know that for an epicyclic gear train, we have this picture you see below. I just tried to draw a simple diagram of what we call an epic cyclic gear train, and we have this particular member. This external surface is what we call the ring gear. In class I tried to explain that in the last class. This is the ring gear, and this guy inside, this gear inside, is what we call the sun gear, which is this guy. That's why you see the guy has a smaller teeth. So this is the sun gear, and that is the number of teeth for the sun gear. And what else do we have? We have the planetary gear. So this guy is the guy we call the planetary pinion. And remember, the other name for pinion is gear. So remember, I'll write them in plural. S, there are three of them. I have this and I have this. So there are three planetary gear. There are planetary gear. It's just like the annulus, the sun, the moon, and they move around a common planet, which we have the Mars, the Jupiter, Earth, all of them move in a configuration. So that is how the inspiration of planetary gear set were all established or derived, by using that concept of the sun, the moon, and the Earth and Mars, how they move together in pairs. And just imagine that and think about that, and that is the philosophy or logic on how this sun gear were actually established. And this guy that connect all the planetary gear set, which is like a ring that put all of them in position, or that guide all of them in their movement, are called planetary carrier, because it is carrying the planetary gears. We call it the planetary gear carriers. So those are the main part which we have, and therefore these are the planetary gear. It is smaller. You see 20 teeth. You see it's very small. And we have the ring gear. We have the ring gear, which is the biggest gear, which is actually this guy outside, which I call, this is the ring gear. You see the guy has 80 teeth. So technically, why I drew this diagram is for you to see the sun gear, the planetary gear, and the carrier for the planetary gear. And that is just the reason why I drew this for you to see. So if you are given this problem, you'll be given this data, and you'll be given this table, and you have to make use of this formula for the angular velocity. And this table is never completed. This table is never completed because the gear ratio table must be. So the final table for your calculation must be given as such. For this is what we call the ratio for the gear, and this is still the ratio for the gear, and this is the angular velocity for the arm. But then the angular velocity for the gear, so this is the final table given. So this is the final table given to be used in to be used in your calculation. So how did this table came to exist? It came to exist by using the ratio for what? For the gear system, which is here we have the first ratio is actually the planetary gear set, but we have to write it in terms of what? The sun gear divided by what? Divided by the planet gear. Remember, this sun gear is minus 40. I will explain that. And this planet gear is 20. And then here, the other ratio is actually the ring gear should be below with respect to what? With respect to the planet gear. So this ratio is the planet gear over the ring gear. So this guy is 80 and this guy is 20. So that is how the ratio are gotten. And for the arm, we have to understand that the arm is the input. The arm is the input. So this arm is the angular velocity for the input. And because we understand that gear set must be well understood, if one gear moves clockwise, the other gear moves anti-clockwise. So the input gear moves in the anti-clockwise. That's why you have negative sign for this value. We'll give it a negative sign for the table, and that is a strategic move, and that's why the table will be given. And the angular velocity for the gear inside also move in the opposite direction, which is minus 100. So take note that direction matters, and they move in the opposite direction. And that's why this table must be given for you to understand how the gear pairings have been moved. And the first thing you must do, the very first thing you must do, is to be able to get the value for the angular velocity for the gear arm for the sun gear and the planet gear. And this value here, let me write it down so you can see. This value here must be repeated value for input to the sun gear. And that input value for the sun gear was actually negative in the initial case, which case this case was negative 100, so here we have to put positive 100. So that value there will be positive 100. And that is why the table is given. So this table is given because when we have the angular velocity for the gear input for the sun, when we have negative, therefore the angular velocity for the arm and gear will be positive. It will just be an inverse because they move. If one move clockwise direction, the other gear must move in the anti-clockwise direction. So take note, the gear train moves in the opposite direction, and that's how the drive is being given to the system. And the first thing is always to get this value for the input to the sun gear. It is the opposite in terms of the direction of movement for this angular velocity for the gear. So if you want to be smart, just look at the direction. Let me use a different writer so you can clearly see this clearly. So to be smart, just look for the direction for on the table for the input sun gear. If it is negative 100, then this direction for the input on the sun gear for the angular velocity in the gear and the arm must be positive. It must be positive. That's why I just changed the sign. And the next thing I want to do now is to be able to get this value and this value. And how do I get those values? Let me clean that. How do I get those values? First, for this value, let me write it here. How do I get that section for that value? It's quite easy. I'll use this gear ratio, which was given on the table. Remember, this table in totality is given, but the spaces that are vacant are the spaces that I'm completing, because the direction and the sense of the ratio and gear arms really matter, and that's why those values are initially given. If it is not given, you have to assume which of them is positive, which of them is negative, but know that the arm and the gear are just gotten from this table of planetary gear system for the epicyclic gear train. And now that I want to determine this value, I'll use the gear train, and the gear train for this above gear, I use this section of the gear to get this, and I use the section of gear to get this. So I'm actually here. Now, for me to get the value here, I'll use the gear train ratio, minus 40 over 20, multiplied by what? Multiplied by this angular velocity for gear arm, which is actually what? Which is 100. And therefore, if I do my multiplication, I'm going to get a value of what? A value of minus 200. And therefore, this becomes what? This becomes, I'll write that in red so you can see, minus 200. So this is how you get that angular velocity for gear arm. And then I come to the next, which is this. I will use but this gear train, and that gear train is plus 20 over 80. I'm sorry for those noise. My kids are jumping everywhere. I'm so sorry for that, because of no school, so they are around. So I have the gear ratio multiplied by what? Multiplied by the topper value, which I just got for the angular velocity for gear and arm, which is actually this, multiplied by minus 200. And therefore, the answer is minus 50. So that is minus 50. And subsequently, that's how we establish the table for the angular velocity for gear arm, minus 50. So if you need to go below, you still use the upper gear ratio multiplied by the value for the angular velocity for gear and arm. And that's how you get the angular velocity using the table method. And now the very last section, which is quite interesting, is the angular velocity for gear. So remember, angular velocity for gear is equal to what? Is equal to angular velocity for arm plus angular velocity for gear arm. And this is the first formula I tried to explain to you. That is the formula you see. That's angular velocity for gear, and you see that this is the angular velocity for gear. It is just this plus this. It's just this plus this, which should have been the same logic you could have used to just get this. You could have said plus 200 minus 200 plus 100, you will get that value. And that is still the same logic. You can equally use to save time. And if I come now to that section, I will just come to this section which I need to solve for this. So let me use a different writer here. So it will become what? It will become for this section that I am here, I have arm plus angular velocity for gear arm. So I have the angular velocity for arm, which is minus 200. So I have minus 200. I have minus 200 plus I have minus 200 minus 200 minus 200 minus 200. Let me minus 200 minus 200, which gives me equal to what? It gives me minus 400, and this is minus 400. Like I said, for this section equally, you are still free to be smart to say minus 200 plus 100, which is equal to minus 100. So for this section, you could still be smart by solving that without even using the initial explanation I gave you. You may just say that plus that must give you that sum. However, you can verify that to see it is going to be the same. And then the last angular velocity for gear, which is this side, let me use a different writer, a color that is quite different now, so you can clearly see the writing color. I'm going to use angular velocity for arm. Angular velocity for arm is minus 2. Is minus angular velocity for arm is minus 200. So I have minus 200, and then this angular velocity for arm and gear is minus 50. I have minus 50, and I have what? I have minus 250. So this value is going to be minus 250. And that is how this table for Epicyclic gear train is formed. It looks a bit crowded because I've tried to write and explain those variable and how the values are gotten, but it's quite simple and straightforward. You may want to watch this video twice, and then you are going to be able to understand how to establish this table. So please make sure you master this table before coming to write the final exam and before coming to take the exam class quiz. So for time's sake, I would love you to also try to do this. Try to establish this table by using the same logic on this, and then see that the answer you get from this table must be the answer that it is on the table in the textbook, and I have the solution available on Moodle. You may try this and verify the answer if it is correct, and that's how you have to establish this table. So please watch the video, and if you have any question, get back to me. God bless you. Thank you.